Hello and happy Monday. This is Miss Cliffner with your lesson, the fourth lesson on the distributive property. Today is Monday and the essential question is how can we use algebra tiles to model the distributive property? Take out your planner and write down the homework. It's a worksheet. I apologize if you're at home, but you can write this out in your math notebook. If you're missing any of the worksheets, it's going to be in the what you missed while you were out, and there's 3 of them that I need to check this week. And then I returned some chapter 2 quiz corrections. If you have some more, I will take those up until Thursday. We're going to look at a warm-up and then some new notes today. So here's the warm-up. Write and simplify an expression to represent the area and the perimeter of the rectangle. So notice that this dimension is the length and over here is the width, right? And then remember that area is length times width. And then remember that perimeter is you take the length and you add it to the width and then you multiply it by 2, right? So it definitely looks like the distributive property as well. You could add up all of the sides, but I want to use the distributive property. So go ahead and pause the video and see if you can figure out how to simplify these expressions. Oh, and it was from homework last week, so this problem should look familiar. Okay, so I'm going to do the x plus 8 as the length and multiply by the width. If you put the 8 on the left-hand side, totally fine. Sometimes I like to switch it up. I'm multiplying the outside by the in. The 8 gets distributed to all of the numbers inside. 8 dot x means 8 times x, plus 8 dot 8 means 8 times 8. So this simplifies to 8x plus 64. That is the simplified expression. I can't do anymore. Okay, the next one is 2 times everything inside using the distributive property. So it's 2 times x plus 2 times 8 plus 2 times 8. 2x plus 16 plus 16, 2x plus 32. That's the simplified expression for the perimeter. Okay, so here we go. Today we're using algebra tiles to practice the distributive property. So I want you to notice this key. Every time you see a gray rectangle, it stands for an x. That's a variable. When you see the square that's filled in, it's a +1. When you see a square that's not filled in, it's a -1. That's the key that we're going to use for today. Here's an example of writing an expression represented by this picture. You see 1x. I'm going to put a little x here. And then each of these things stands for -1. So altogether, I have x minus 3. That's an expression that represents the picture in algebra tiles. All right, let's look at another example. This time I have 1, 2, 3 x's. So I have 3x. And this represents a positive, so it's 3x plus 1. Now I'm going to have you try writing an expression. So here's your OYO. Pause the video, see if you can write the expression using variables, coefficients, and numbers. So there's 1, 2, 3, 4 x's, and then there's a -2. Okay, so now we're practicing going in the other direction, right? And so I'm asking, did you know that drawing a picture, it's a basic math strategy. If you don't know what to do to solve a problem, sometimes drawing a picture helps. So we're going to use algebra tiles to represent the expression. So now, this time, we're basically translating the math into a picture. So I've got 2 x's. So I'm going to go to my fancy little duplicate machine and make 2 x's. And then I need to make a +4, which is the filled in squares. And I can just put 1, 2, 3, 4. That's a picture that represents the expression, 2x plus 4. All right, here's another one, 3x minus 1. So I need 1, 2, 3 x's, and then I need 1 minus 1. That represents 3x minus 1. So the -1 is a constant. Remember that the 3 is the coefficient. It tells me how many x's to make. So here's an OYO. Try this one on your own. Draw tiles to represent x minus 4. I'm going to go ahead and put a phantom 1 in front of it. That just reminds me, oh, that's right, there's only 1. So there's my 1x, and then remember the minus or the open or empty squares. So there is my x minus 4. Okay, next part of the notes. This isn't in your notes, but I want you to see this is the process I'm going to use. Notice that I have two equal groups, and inside each group is 2x plus 3, and this is 2x plus 3. So I've got two groups of 2x plus 3. There they are written out. Then what I do is I group the 4x with the 6. There's my 4x's grouped together, and there's my 6 1's grouped together. So once I combine like terms, that's what the right-hand side looks like. The left-hand side looks like groups with parentheses, and the right-hand side looks like I've done some distributing and combining like terms. Okay, so here's an example. Notice the first thing I'm going to do is look for how many groups there are. 1, 2, 3 groups. So I put 3 on the outside. What's inside each group? 2x minus 1, 2x minus 1, 2x minus 1. So 3 groups of 2x minus 1 is equal to a total of 6x minus 3 when I combine the like terms. All right, next, count how many groups there are. I see 1, I see 2. So I've got 2 groups, and what's inside each group? I count 6 x's plus 5, 6x plus 5, 6x plus 5. So this is 2 groups of 6x plus 5 is equal to, when I do the distributive property, see how that's matching? I'm going to come up with 2 times 6x, 12x plus 10. All right, now you have an OYO, and then it's time for the homework. So first count the groups, and then write the expression with parentheses, and then write the expression without parentheses. So notice 3 groups, and there's 3x minus 2 inside each group. 3 times 3x minus 2. When I use the distributive property, I multiply 3 times 3x to give me 9x. Oops, I need to put that down here. Minus 6. 3 times 2 is 6, and I'm subtracting. Okay, so now for the, I'm just going to give you a quick check of, do you think the student has done distributive property correctly? So here's the first one. If you distribute 4 to 2x and the 4 to the 1, does it equal 8x plus 1? What do you think? Thumbs up or thumbs down? Hopefully you're thinking thumbs down because they forgot to distribute the 4 to the 1, so that should be 4, so it's wrong. All right, here's another one. Let's see if they did the distributing correctly. 5 times 3x is 15x. 5 times 2 is 10. It's a minus. Oop, it's a plus. Thumbs down. Next one. Let's check and see. 7 times 3x is 21x. 7 times 1 is 7. There's a minus sign. There's a minus sign. Awesome. Thumbs up. Last one. 3 times 2 is 6. Ooh. 3 times 6x is 18x, and there's a minus sign. Oh, this is weird. Now, what I'm noticing is this has a plus 6, this has a plus 6, this has a minus 18x, that has a minus 18x. Oh my gosh, this is a thumbs up. They use the commutative property and switch the order. The answer is the same when you switch the order. Okay, so here's what the homework looks like. The first 2 problems are asking you to draw and create the equivalent expression like we did in the notes. So notice you're starting with 3 groups of x plus 1. So here's my x plus 1 is a positive. And I need to make 2 more groups because I have to have 3 groups. So there's 3 groups of x plus 1, 3 groups of x plus 1. And I'm going to circle so that you can see that indeed I have 3 groups. And then over here, I group the 3 x's together, and then I group the 3 1's together. And it equals 3x plus 3. That's what you do for the homework. Okay, good luck.